once you oversubscribe it like you did on a Cray, you then start thrashing on secondary cache. Crays do not have secondary caches, at least the vector machines. The T3E machine, the cache was so small, it didn't matter. 64 kbyte is not as much as an 8 megabyte secondary cache. So just going back to my example here, fix the user and application issues first, resolve your file system and I/O issues, deal with your CPU scheduling, then deal with your memory. That doesn't mean I may not deal with memory issues sooner. I'm just trying to give you a methodical approach. All these other things are going to affect memory. For example, with Nastran, when I start Nastran, I can say, how much memory do you want to use for scratch space? If I make that larger, then I can reduce the I/O demand on my system. But now my memory footprint is bigger, and that affects everything else down the line. So in reality, memory is dealt with between every step as well. Anyway, I normally plan on getting out about noon on Friday. Okay, that's the plan. Basically, the layout is today is inventory. In other words, what do we have? I have to get the system in shape. I have to get NQE working. I basically have to get the system roughed together. Okay. At the lunchtime and after, I'm going to start submitting work and starting to stress the system. That's something that a lot of system administrators don't do. They configure their system, but then they don't throw a load at it to see what it does. Or if they throw the load, it's such a light load that it could handle it. But then I tell the user community, okay, log in and use my machine. Then I've got my problems again. A lot of SGI people tune and do all their work on a single application situation, whereas the customers are running multiple jobs of multiple different types. Let me give you a clue here. Cray people, when we have a benchmark, when they had a benchmark, one of the two things they try to do, if the benchmark is not winning the competitor, there are two things they try to do. Clarify the job mix. In other words, in the SGI world, a lot of the benchmarkers run one run of the application with no contention on the system from anybody. But then it goes out in the real world and you've got 50 people using that machine. So the Cray people always try to say, well, let's run 4 copies of this, 4 copies of this, and 4 copies of this, rather than just a single job stream or a single job at a time. The second thing that Cray benchmarkers try to get you to do as a customer is to up the size of the program model. In other words, if I'm doing a car crash and it's on a 1-foot grid, I may go to a 1-inch grid. More data, larger arrays, we bust secondary cache, and that's where Crays start showing up. So those are two techniques that are often done to show your features, the things that you're able to do better at the high load levels than other systems out there. We're going to talk about something called bottleneck curves. What I'm saying is down when you only have one person on the system, you're at unity. As you add number of jobs or number of processes or whatever on the system, your elapsed time is going to get worse. And that's what a bottleneck curve is. And I'm saying a lot of people try to benchmark their bottlenecks down here, and then the customer runs up here. And then they get different performance. So it's not uncommon for me to do benchmarks down in here, but I, in this class, am more concerned about real world where I want to know the shape of this bottleneck and how can I control the shape of the bottleneck. Add more memory and I can go further, things like that. So anyways, today is what do we have? I want to talk about basic methodology, and I kind of started introducing that now. And we have to go through system configuration real quickly. And this is what we were talking about earlier. I have to do an inventory. Figure out how many CPUs, how much memory, how many disks, how big are they, how's my file system laid out, all these basic questions. Now to save you time, I have a script written called bsystest. And it will run everything from systune to versions to HINV to XFS GrowFS to get all of your configuration information. Everything that it can get off the system. So I don't have to go back to the customer 15 times and say, what do you do here, what do you do here, how's this set, how's that set. Now eventually I'd like all of that into ESP, because ESP does get HINV, it does get systune, it does get versions, but it doesn't get file system layouts, for example. Okay. But that's what I mean by system configuration, figuring out what do I have. And then I want to get into system analysis, and that's basically getting into instrumenting. And with instrumentation, I'm going to turn on SAR, Performance Copilot, accounting, SAT data, CSA data, and there may be other pieces too. Some require reboot, some do not. So SAR and PCP are simply two interfaces to the same set of data. ACT, SAT, and CSA are three different interfaces to the same data. Though CSA, for example, gets a lot more metrics than standard accounting. Now I'm going to have a lot of tools, and that's why I gave you an outline to kind of give you a list of the tools that I would use as I go through the process. So it's kind of your checklist, in the order that I need the tools. One thing I don't like about this class is there's a monitoring tools chapter, and I would prefer to cover the tools within each area. But for example, Performance Copilot covers CPU memory and I/O. So those are some of the basic things we'll cover there, but not the specifics of the metrics. And generally what I try to do is by the end of the second day, let me erase this now. By the end of the second day, I have a baseline. In other words, I've profiled the applications, so I know how big they are, how much memory do they take, how much CPU time do they need, how much I/O do they do, what's the type of I/O, are they reading more than writing, writing more than reading. This is what I call workload characterization, to characterize my workload. For example, media base, a video server, I would expect that to be reads more than writes, as I'm having people read movies off that web server. Okay. If I have a machine that's taking satellite image data down and putting it onto a website, I may be writing more than reading as the video stream is coming down from the satellite. I need to understand those questions. Okay. If I'm writing more than reading, I may not want buffer cache. If I'm reading more than writing, caches can help me. And we are going to look at compiler options here, so the F77, for example, dash capital O3 is going to be the only real compiler optimization that we're going to do. There's all kinds of other options on there, but we don't have the time in this class, so just want to do a couple of basics. And the key thing that we're going to profile in here, by the way, now is a command called ssrun and perfx. So that's where I hope to be, is by the end of tomorrow to have some baseline, some starting data. First question is, what do I have? Second question is, where am I? How is it performing? What's my baseline? What do I have? Now typically in this class, application tuning single-threaded is covered tomorrow afternoon, and then Wednesday morning we get into multi-threading. So that's the way it usually works. If I can get multi-threading started on Tuesday afternoon, that's great. But typically I don't. So what usually happens is file system performance gets covered in the afternoon. So the third day, we're going to start with tuning. So in tuning, I'm going to do multi-threading. And again, I cannot change the source code, so the multi-threading I'm doing is the -APO, automatic parallelization option. I can't go into the code and change anything in the source. And then we get into file systems. I really don't have any good labs for the file systems. We're going to talk concept, but a lot of the labs are back in the advanced admin class. But what we're going to start doing is stressing our system and taking a look at how our system configuration is for codes 1 and 3 that do the I/O. But I don't have the ability to go out and repartition a lot of my drives and stuff. In fact, it's not my file system. If it were, it would be designed completely different. And you'll probably see that when we start looking at file system layouts. They did a lot of bad things in the system. A lot of bad things. Thursday then is more tuning. And Thursday really is CPU and I/O. By I/O I mean buffer cache. Whereas this was disk I/O. And then Friday is basically wrap up. Friday I am usually talking memory and page migration. There is a thing marked here for NQE. We really won't be doing that. There was a CPU lab where we used to run fair share scheduler, share 2, but we don't have that option anymore either. So Friday's just kind of clean up, wrap up, tie up loose ends, and in particular get the memory pieces done. So that's really the layout. I've got to get my system in shape today. I've got to figure out what my numbers look like tomorrow. I've got to start reacting to the data and getting my system tuned. During the CPU, we're going to kick in miser and also something called CPU sets to see if that helps us. Okay? Believe it or not, I used to have to do this in a 3-day class as well. That's an older schedule here for a 3-day class. So there's a workbook. There is a lab book for Pesto, but I don't hand it out primarily because you can't do them, and a lot of the exercises are kind of nonsense. They have you go through the task, but you don't get anything out of the exercise. And the main thing then is I've got sample codes. They're all going to be in user people DAW. So in your workbook, if you have this slide, it's user people DAW. That's my home directory. So I'm going to show you where to get the programs. I'm going to show you where to get the various shareware tools that are supported by me. Is that undo? Yes.
Undo?
Yes, undo. So I'll get you to that here. And it's just kind of showing here that under there's a whole bunch of subdirectories. I don't really care about this. The main document that we care about, by the way, is Insight's Configuration Operation Guide. So I'm just going to bring up Insight. The one that we care about here is System Configuration and Operation. This one here. We're going to click on that, and in there, the main thing that we're going to care about in the week is our system parameters. So some of the things I talk about will be Chapter 10 here, System Performance Tuning, but it's really Appendix A. I'm just going to click on that. And then here's where I have all my parameters documented. For example, nbuff. Let me find nbuff here. And there's the description for the nbuff parameter. Not all of your system parameters are documented here. They can't keep current with what the overlay levels are doing, but they do a pretty good job of keeping up. Okay. But just because there's a system parameter that's not in here, that simply means they haven't added it to the documentation yet. No, I don't think I've got it here yet. There is another IRIX admin guide that's been added that's called a Workload Management Guide. And that came out in 6.5.8. I'm assuming my workstation is older. Little a, big R. I'm at a 6.5.6 release on my workstation. There's a new resource management guide, and in there is miser, accounting, and a few other pieces. Job limits, user limit database is another piece. Besides that, then there are various release notes. I go to info.inger quite a bit. So that when I've got to upgrade to a new release, info.inger is where I find out what's the path to install from and to upgrade and procedures and all that sort of stuff. Man pages we're going to use most of the time. Thank goodness for man pages, right? I'm not really going to be using any of the other pieces, but there's SGI help. There's Pipeline newsletter, usually has an article every month on tuning or performance issues. And then my web pages. And that is an old address. There is a list of books available. Got that in both your manuals. I'll just leave it alone. And why don't we take another 15-minute break here?
Because of my log, most of the time, I think I'm making, 2 times I did, I'm making a mistake. I went to see the limits and I increased the limit of the memory used per process on the kernel.
Yeah.
I actually then, they most of the time they call back and say, well, I have given that unlimited, but I have all this memory and, my process is not using it. So it means that it's not really that. You need to look at these parameters, right?
There are other things to look at. Now, what I was trying to say here is that Miser will pre-reserve your work.
Okay.
And that's taking 1.5 gig. Also, what's called shared memory is also reserving memory ahead of time. Now, shared memory, IPC, it's up to the program to release the memory when they're done. If the program gets killed for whatever reason, such as a process limit, then the program does not have a chance to release those resources. So I had one site, University of Dresden, looked like a memory leak. Their memory reservations just kept going up and up and up and up. What was happening was their NQS Gaussian jobs. Gaussian is a chemistry code. In the Cray world, it did not use IPC, but in the IRIX world, it does. NQS was killing the Gaussian jobs due to limits, and then the job did not have a chance to release the shared memory. So the memory reservations just kept going up and up and up. So again, I could have added more memory, I could have upped limits, but the real issue was to go back to the application that had the problem and release all that reserved memory. So before I jump off onto these things, I want to make sure, are there any IPC resources defined? So IPCS just gives you everything. There's nothing there right now, IPCS-AM. And I would be looking for things that have n attached equal to 0. And it also gives me the size, how big that shared memory is.
Oh, so that n attaches the amount of memory that a
N
process
attaches the number of processes that are assigned to that shared memory segment. But the process could be killed and the shared memory segment is no longer attached to anything.
but still
Allocated or
allocated.
reserved.
Okay.
So then you do, it's a IPCRM to remove those things. So I had an Oracle case last week, the messages or the semaphores were failing. And I asked, first of all, check with IPCS to see how many semaphores you actually have. And if they're unattached, get rid of the unattached ones before you up the limit. Because if you up the limit, that simply allows you to be more abusive. Okay? So I'm just saying, fix the application first. So those are two things. So if I can refine things here, this is everything. This is just for running processes only. It does not include processes that have been checkpointed. It does not include Miser. It does not include IPC. And IPC, the shared memory, is allocated out of memory. So like this Dresden site, it'd keep allocating shared memory, and then NQE would kill the job, and the program would never release the shared memory that it was using. So it just keep reserving more and more shared memory. And then the third one was Miser. When Miser starts up, it's going to pre-reserve things.
So really in the n attached, we're looking for a 0, right?
Correct.
That's the number we want over there.
That says it's not attached to anybody, it's not being used, and I can remove it.
Okay.
And IPCRM is how I can remove unattached segments.
And in the case there is one process over there. I know that it's attached to that process. How I can find out what process is attached to?
It has it in there. There's a PID and stuff like that in there. IPCS. Process number information with a key option, for example. Time information, when it was last manipulated. The A was all the print options. Okay. So I don't have anything here, IPCS-AM. Nothing's visible here. None of my codes are actually using it yet. Okay. So in my inventory process, the only thing that I have using memory right now is miser. Now I'm going to leave miser running because I want to use it on Wednesday. So I'm going to live with that reservation. So my next option then is to look at virtual swap. I'm just going to check for swap. And virtual swap right now is turned off. Just to keep us moving, I'm going to turn virtual swap on at this point, because that will allow me to run more of these programs. Root. So without buying any more hardware, I'm going to push my virtual memory size up. Now I haven't actually started it yet, so I'm going to go into config and cat swap.options. Vswap.options. And in there, that's the size of the virtual swap that's configured. I'm going to up it, just to keep us going. Now eventually we're going to run out of virtual swap anyways, and things will still die. No matter what you do, you always have limits. So I'm going to turn it on. init.d swap start. Hold it before I do that. Swap-ln. I only have dev swap as my swap device right now. So now if I do my init.d swap, swap start, init.d swap start. Now if I do my swap-s, I still see 1.5 gig available, but look at, well actually it doesn't look like it changed much, the amount available. Let me also check now swap-ln. And I added 381 gig of virtual swap to my system. And it's not showing up with swap-s because it's virtual. So, the other thing I could do is add physical swap, but I'm going to save that for later, because I don't want the swapping going on yet. I don't want the load impact of it. So I was responding to code 4 failing. Now I'm going to try to run code 4 again. You can see how far it can go before it dies. So now code 4 is at about 789 meg. It was blown up at about 500 meg before. But again, since it's a sparse matrix solver, it doesn't use all of the memory that it asked for. So the physical memory it's actually using is 484, which was less than the 600 meg that we physically had available. So it is successfully running now. Okay. But I could have done the same thing by shutting down miser. But I want to leave that reservation there. I could have done the same thing by removing any shared memory that hadn't been released properly. I could have added more physical swap or more physical memory. Or I could have made the program smaller. All different options. It costs money to add hardware. Okay, so I want to make sure the application is properly sized. And then playing with the OS, that's what I was doing here. I added virtual swap. I could have removed miser. I could have added more physical swap. I didn't add physical swap yet because I don't want the load. I don't want the I/O load. I don't want the swapping load to hit me yet. I want to add these problems one at a time. So now code 4 should be successfully running. So at this point, what I'd like you to do log in to do with the TNG accounts that I gave you. We're going to take a break here as well. Your workstation is just a window into do. You won't find programs or anything like that on your workstation. So everything we're doing is on do, all on the same machine. Change your password, just so that nobody else messes with whatever you're doing. You can't blame me, kind of problem. And then what I want you to do is copy ~DAW/.login into your home directory. And also copy ~DAW/.profile into your home directory. And I don't think you'll need it, but .cshrc would also be one to consider. But I don't think there's anything unique in there.
That's for C-chat, right?
Yeah. But if I'm logging in interactive, logging in CSHRC are important. The batch work is going to be using this one. So I'm trying to get you your environment set up. Next, I want you to make a directory called RILWL. So these are the workload that I'm going to give you. Okay? And then copy ~DAW/RILWL/*NQS. So you're going to grab the NQS job samples that I've got for you and copy them into your own directory. Okay, so you're going to copy my jobs for me. You don't need the source. All the jobs will point to my source. So all you need are the jobs themselves.
We need a CD in there, don't we, between the maker and the copy?
Not yet, but I was going to CD. See, I copied them into RILWL.
Oh, okay. Okay.
But you're
That
right.
would be the home, that real WL would be in our home directory also?
Not yet. So you're going to make it. Mine is already there.
Okay.
So you're going to make your own directory. If you already have one, it's from a prior class. And I'd recommend just removing it and starting clean. And then copy mine. And that's what I was trying to do today, was get the jobs running before I give them to you. They're not going to be perfect, but they're at least a starting point. Because I want you to be able to make changes to them. Then CD into RILWL. And then submit the jobs. So then you're going to do a qsub code1.nqs, qsub code2.nqs, and qsub code3.nqs, and also 4. Okay. So I'm getting your environment set up, I'm giving you job samples, and I'm going to have you submit them. Now when they're running, a qstat-a will show you the jobs that are running, so you can monitor them. And then when they come back, ls-lt, pipe it into head, jobs come back in the current directory you submitted from. So that in that RILWL directory, they're going to come back as a .o type of file. When it comes back, for example, it'll be a code1.o, and then whatever your sequence number was, like 37 or whatever that particular number was going to be. So let's see, that code 4 is still running at this point. So if I do a qstat-a, there's the code 4 that I submitted. Okay, and it's still running. When it comes back, it will show up as a .o16 as an output file. So I'm still in RILWL, LSLT will show me my most recent job. And here, for example, is code 3 running. So when it comes back, I want to view the output. There's my message of the day. This is your .profile. And the actual job, and in fact, in this case, it took 69 seconds this time. Okay. And then lastly is the job report. seconds here. A little surprised, there must be it must be a wrong JAC file. So I'm going to have to watch for that. But it's only showing 3 seconds here for some reason. See, that JA should have been picked up. So it's code 3.2. Anyways, that one code forward has come back now. So there it is, code 4.16. I see the compile. And here now code 4 ran successfully this time. 364 seconds of wall clock, 359 of that was user. 4.5 seconds of system time, and we can't see anything else. And look at the size, almost 500 meg in size. So with the 2 gig system, I can't run any more than 4 of them before I start swapping. Now what I'm wondering about is the timings. And I have some sort of problem going on. My JA reports are not, well, 329 seconds, that makes sense. I'm seeing other things that aren't part of my job. Wrong job IDs. So I'm just going to have to watch that. With that, let's take a 15-minute break, and I'm also going to give you 15 minutes to go through this and see if you can get the jobs running. Okay? Here's of these jobs. These are unoptimized. There's going to be some O3 jobs that are optimized. There's going to be some MP jobs for multi-threading, things like that. So you're my user community. I'm your data center manager. I've given you hardware. I've given you a workload. So you're pretending like you're submitting these work and then seeing how long it takes them to do things. Okay? So we're starting to get a baseline. And we're going to go into that tomorrow morning as well, getting the baseline. And then we're going to start optimizing. So, as Warren had mentioned, TimeX gives me my timings. SSRun does the exact same thing, but it gets to some additional numbers as well. But I can't depend upon you to send me SSRun results. And most people may not even run under the TimeX command. So I have system accounting turned on to help me do that. Now right now, the only problem I have is still NQE. The developer is going to look at that tomorrow morning because I wanted a working NQE the rest of the day for us to run jobs. So I don't want to go back to this .16 release until tomorrow morning. And then while I'm lecturing, I'll give them a chance to look at it. Also, before break, we were noticing JA problems. That's again because NQE doesn't support job IDs. So JA doesn't know which job ID to extract the data from. So we're getting all the jobs intermixed. So JA is not working right now because of that. It's giving bogus numbers. But as far as the end user goes, that's what we'd be looking at is the summary report that gives me the times and stuff like that. And this is where I left before break saying, well, where's the command? It's not showing up. These are all at the job ID of 0. So JA is going to the job ID 0 for all the data. And that's why it's failing. But instead of doing that, there are 3 commands to get to accounting. ACCOM is the first one. We're going to get into this in a couple of chapters here, but if I do an atcom-n code 1, and it looks like I've got a few files here, atcom-n code 1, var adm kcct asterisk. What I'm doing, also let me get a dash m option. What I'm doing now is getting a baseline for my codes. Okay, so go ahead and try this on your system. And except for this code right here, the rest of them are all in the 65 to 69 second range. So what I'm doing is trying to characterize these things. And I'm just going to make a note up here now. In other words, where am I? Where's my starting point? I have to get a reference. If I want to make these things faster, I got to know what they typically are. Okay. So with the atcom command, I'm just going through and looking at all the CPU times just for code 1. So it's like having all the timex reports in a single file. These will match timex or ssrun. So for CPU, code 1 is about right now, I'm just going to mark it as 66 seconds. CPU time. And for memory, they're at about 16 meg. This is in K bytes, K. So they're about 16 meg in my memory size. And the other thing that I should characterize is that I didn't here and should have was the I/O. I'm going to do that again and stick an I on there as well for I/O statistics. And now I can see the I/O count as well is about 134 meg of I/O. Okay, so I'm using the atcom command, which is standard Unix, standard System 5 Unix. Crays have it as well. Linux does not. Eventually Linux will have the CSA package in it. So I'm grabbing CPU time, memory sizes, and I/O. What was that?
Where did you get the I/O again?
This field right here, I have a wrap, unfortunately, to keep the fonts large enough, but characters transferred was this one right here. I had to do an I option to print that out.
Oh, okay.
So I'm getting CPU, memory, and I/O all off one chart. So I'm going to do that for code 2 now. I don't want the multi-threaded versions, I just want the single-threaded versions. And they should be, I've got some different runs here, but 1987, so about 2,000 seconds in CPU time for code 2. But I've got some other ones running in here that were optimized, and also this multi-threaded version, which by the way came in at 175 seconds. Remember I said 166 was the record? If I can keep it under 200 during the whole week, I'll be happy. So that's what we're eventually going to be watching, is when I multi-thread. In this case, it's 1, 2, 3, 4, 5, 6, 7, 8 threads wide. So it went 8 threads wide plus a master thread that's checking with everybody to see what they're doing. We'll talk about OpenMP when we get into Wednesday morning. And then this one I just kind of threw away because the actual timing for this thing is about 280 seconds. Single thread, so that looked like an optimized version, or else it died early. And then 405 was another code 2. Looks like that one probably died early. And if you look at the I/O counts, for example, you can see some differences there too.
So what, that's in seconds?
Yes, over here. These are seconds. Okay.
Okay, yeah, and the I/O is in what?
Bytes.
On
or
bytes,
characters.
okay.
A character being a byte.
Alright.
And then memory was this mean size with a K in there indicating it's a K, and then I slide it over 3 per meg.
Okay.
So if I talk to a customer and they say we're a Nastran site, I can go into the accounting data and see what their Nastran runs look like and get a reference. And then I say, is it all CPU service? Is it CPU weight? Is it I/O weight? What major elapsed time component do I have? Now, in these cases, for example, this one was 1997, but it took 2152, so there was almost 3 minutes there difference. So as a system tuner, I'd like to know, was I waiting for CPU, waiting for memory, waiting for I/O?
The difference between those two
Would be my wait times.
would be the wait time, okay.
So as a system tuner, it's the wait times that I have influence over. The application tuner controls this, but the system tuner controls the difference between the service and the total. So the total includes anything I have to wait on. If I have to wait for CPU, wait for memory, wait for I/O. If I go to sleep, that's not counted, but that is part of the real clock time, but not part of the service time. So I'm just getting numbers here, and unfortunately I don't have enough code 2 runs yet, but I've got 2 that are in the 1990 range. So I just picked it at 2,000 seconds. It's a little bit less than that. And for memory size was 22 meg. Again, I wanted to avoid I/O, so with code 2, characters transferred to 0. Or in this case, I got 1,600, 1,500. So it's about 1,500 bytes, it looks like.
How you got that number so small? Oh, that's for
Which number?
the character transfer.
Why are those small?
No, you got those very, this at the end are really small, but then you have that one that says 218726.
Which is real big.
And I got something like that, you know?
Uh-huh.
So I just wonder why is such a big, huge difference?
We'll have to look at that more closely. That could be profiling. If I ran it under SS run, things like that, there could be additional characters moved. It's a good question, and we'll come back to it as we look at things. Now these are multi-threaded, and there's no I/O in the multi-threaded portion, so there's 0. And then the master thread, when it did its I/O, came out at 2625. Normally it's about 1536. For some reason, and I agree, I don't know why off the top of my head, but it came out to 21 meg there. An example that might cause that is like Perfx or SS run, where I profile the application.
Why is there a pound sign at the beginning
Pound
of that
sign says it
line?
ran as root.
Ah, okay.
So if there's a pound sign in the front, it was a set UID or it was a root type of program. So I had SU to root, but my real ID was still DAW. These are all valid questions. Now we're only looking at 10, 15 samples. What I try to do is look at a week's worth of data to see the trends. You got to have enough data to be confident in the interval. That's why I hate looking at 5 seconds and saying, here's your problem. Because that 5 seconds may not be the same through the whole day. So it's what's called a confidence interval. I got to get enough data to be confident in what I'm doing. Benchmarkers. I hate to be a benchmarker, run the benchmark once and say, oh, that's the greatest number, and then go sell it to a customer. What you really need to do is run it 10 times and see how much variance there is from run to run. Now the benchmarker will still pick out the best run, but they still want to say, but it'll vary in a certain range. And cache-based machines are going to have variance in their run times because of secondary cache activities that we're going to talk about. So right now I'm simply getting a reference of saying, what do I got for my programs? How much CPU do they need? How much memory do they need? And how much I/O do they do? Okay? And with ADCOM, I'm just going into the data for it. So let me look at code 3. Code 3, again, is about 60 seconds of CPU time. A little bit less than code 1. For memory size, it's quite a bit smaller. It's on the order of 2 meg, 2 to 3 meg. And I get a whole range here depending upon memory loads and stuff. I'm just going to pick 3 meg. And for I/O, it's 368 meg. And if I wanted to look at just my own, I could put a -U. There's a whole bunch of ADCOM options on there to look at things by user ID and various other attributes to filter the data. By the way, let me just see here. ADCOM, bar, ADM, PIAC, asterisk, pipe into the word count. So I've got 12,000, almost 13,000 records that I'm looking at, and I've just extracted maybe 10 of those 13,000 records. Okay? So code 4 was the next one. And that one, I had some die or fail earlier, so those were the ones coming out at 2 or 3 seconds because there wasn't enough memory. But in general, it's looking at about 360. I'm going to go with those numbers there at 365 seconds of CPU time. And for memory, these are much larger. 493, I'm going to mark them as 500 megabyte. They're actually 494. I'm just picking a rough number. So those are 400 megabyte in size in memory. And for I/O, it's 512 bytes. Now when we're counting this I/O, this is just disk I/O. It does not include network I/O. Okay, that's just how much did I do on read and write system calls to the disk. So, if I look at this now, I now can start forming my classes. This one here is my big CPU. At least right now. 2,000 seconds compared to the others, that's big CPU. This one is 400 megabyte in memory, so that's my big mem. Okay. And then I've got these two, which are I/O. So I'm going to call this one big I/O. And this one I'm just going to call medium. It's medium everything. Medium I/O, CPU, really medium I/O. So I'm creating classes and simply saying my code 2s are starved for CPU time. My code 3s and 1s are starved for I/O. My code 4 is starved for memory. Those are the biggest resources that they use. Okay?
So you basically what you say when a customer have a problem, you have to look at what they're running and then look at that data like, who's taking more CPU, who's taking this, each of the resources and trying to classify.
And I'm in a complex environment here with multi-users on a big system. A lot of customers may call in and it's just a workstation, and that's a more simplistic situation. So on my workstation, for example, I may not have accounting data. But in this class, I'm trying to put together all the techniques that are used when you get into large compute servers. So I'm going through a lot more detail than I might with somebody that calls in with a $500 system that wants tuning expertise. Okay. But if it's a $200 million system that's been put into Los Alamos, I'm going to do every little technique and use all the data that I have. Now the person that's programming may know this stuff. So they know when they run it with top or something else what its numbers are like. So they can get the numbers for themselves, but I'm looking at the whole system now. So I look at all the different users and all the different programs and see what they're doing. So I can do an ACCOM-C and say anything over 5 seconds. And now I can see all the programs that were over 5 seconds in size, which did include a find, and a config-mon command, a performance metric data collector for PCP. So there were other pieces in there, but I filtered out all that noise and only looking at my bread and butter codes, and that's why I've called them code 1 through 4 to make it easy for me.
This file is in size of what?
What's the question?
Because you say that those that are more than 5, and that's the size.
5 seconds.
Oh, in time. Okay.
Yeah, it depends upon the options. What I did here was use a capital C that said 5 seconds of user time.
Okay.
There's a ton of options, and only by using it do you get to really see all these different options. So I can filter, let's see, I was using, I can do it by terminal. This is a security issue too. If somebody came in and did an RM, I could find out who it was. If they SU'd to root, they'd still have the same terminal connection. I'd be able to use this file and trace back the SU and find out who just removed root. So I can filter by line, I can filter by user or group. By command name, that's what we've been using. And also then things like the I/O. So system time exceeding certain time, or characters moved. But this is the one that I had, total CPU time, or characters moved. So I could do an ACCOM-I and say 100K. Anything moved more than 100K.
That's the default of our ADM process.
Yeah, but we're going to talk about this later, but if the file gets a certain size, it switches, and then you've got multiple PAC files. So that's why I'm not using the default, because I've got more than one file for today. And now I can see compilers, mostly compilers it looks like. A couple of things. Kind of interesting to see a Q sub there. But so all I'm doing is taking my numerous records that I had and filtering them out to just the ones that I'm interested in. Now, 3 commands. Atcom is for what's called Standard System 5, Unix accounting. Crays have Atcom. Most Linuxes do, or most IRIXs do. Linux has something similar, but it's not as friendly yet. The second command is called ACCVT. ACCVT is from the SAT data, or Security Audit Daemon software. Now this has additional information. The standard ATCOM does not have wait times, for example, whereas the SAT data does. So I can get the same information, but instead of a PAC file, I'm going to a different record type. So I'm going to go into var ADM SAT, and in there are all the SAT files I have on my system. Okay. And SAT was covered in VAS admin. We just got it installed and we're using it. So if I do a sat reduce on these SAT files, pipe it into ACCVT, then I can use an option called OATCOM, okay, -n, code, page it. Now it's a different set of records, but the same basic information. So there's my code 1s. This one was at 24 seconds. Code 3 at 61 seconds. Here's that multi-threaded code 2 that we saw at 175 seconds. Here's code 4 at 323, 495 megahertz or megabytes in memory. So ACCVT is giving me the same sort of information, but I can add additional parameters onto it. Like a W option will give me the wait times, which was not available with ATCOM. I'm going to page that. And now here I've got CPU wait, I've got cache IO wait, and I've got disk IO wait. So as I'm going down the list, I can see whether any of those were kicking up, and they are not presently. They're all a little bit of CPU wait time there, but not bad. Here we've got some cache IO wait reaching 7 seconds. So here's a code 1. It took 77 seconds to get through the system. 67 seconds was user time. And then there was 7.5 seconds that was waiting on my file system buffer cache. And I can only keep track of that by watching my columns at the top. Okay. So having the accounting data lets me look at the timing and say, where am I spending all my time? Here's one that was 12 seconds. 60 seconds to run, 82 seconds total to get through the system. 12 seconds was waiting on I/O. I presently, with all these numbers, and seeing I/O waits higher than CPU waits. Here was a code 2 that took 92 seconds of direct I/O wait, going straight to disk. Another one here that took 125 seconds going to disk. So, ACCVT was my second command. And it's going to be the same sort of data, but there's more to it than we had with System 5. The new one is called CSACOM. This is a port from Cray World. So CSACOM is part of my CSA package. Eventually, I would get rid of these 2 packages, but for practical purposes in this class, I'm running all 3 so that we can compare them and learn to use whichever's available. But CSA accounting is more common for your compute server markets. So we just call it CSA. So now I can do the same sort of thing, and this time the data is in a different location. I don't have to be root to get to the data, by the way, so I can do a CSACOM -n code 2, and now I can see all the code 2s that we're running and see the same timings that we had before. In fact, a few more code 2s have finished now, and I can start to see my 2,000 second range. Note here now we had a code 2, 2222, 9997. There's 222 seconds that were missing in my elapsed time. There's about 225 seconds unaccounted for there. So if I do my CSA COM-W-N code 2, I now see that at least 151 of those seconds was waiting on disk. Okay. So if I know that my program took an hour, and I can break that hour into CPU service, CPU wait, IO wait, I pick the biggest thing, and that's what I'm concerned about, assuming it's my important application. But again, database servers, web servers, I don't have this sort of data. So I have to make some assumptions when I don't have timing data like this. But the purpose of this class is to use everything that I have in the arsenal, all the tools that I can get to. And if the accounting data is there, learn to use it. Now, kind of a bad time to introduce this right now, but I have a tool to help everybody with this. I wrote it for this tuning class and originally wrote it in Unicode. It's called SPV. So go ahead on your system and type in SPV and hit carriage return. It's a tickle script. I used to have them in board script. Okay. I've not modified it for CSA accounting yet. So what I've been doing in the past week was working on some coding to be able to use this data because it's been fairly new for me. I've been playing with it all year, but I haven't had NQE supporting it and giving me NQS records. So I've got some modified scripts that I'm doing. So I wrote SPV to make it easy to look at the system. You can give it away to customers for free. My email address is in it. They give it out in the customer version of this class. And lots of people like it because it's free. Okay, that has its limits too. What it's doing is awking the ASCII reports and then plotting with a program called XGraph and XPy. So these are all in my toolkit. When you get done with the class, there's a tar file that contains all the tools that are not standard IRIX. This is one of them. Okay. So from this, I go through my process. I'm going to look at my hardware inventory, my software inventory there. Then I can look at SAR data. This will awk my SAR reports and visualize it for me. People don't like SAR because it's not a visual tool, but that's what this tool was written for. I can also look at PCP data if that's available on my system. And then I've got my accounting data, top program, top user, top group. And the data that I was just pulling off there, I can visualize with ATCOM and ACCVT. And I'll talk about the PAR button Wednesday when we look at I/O request sizes and stuff. So there are two sites here that we're interested in looking at their system. I can run this not only as a Tickle GUI, but from a cron event. Okay. So the two people that had interesting machines, there are two files that you want to mail. One is just called SPV, and that's the Tickle script. And then the other one is called SPV_batch, which is a batch command to tell me what reports I want. Okay. And I'll write up email and get you a copy of this so you can send it off to a support person. I'm going to quit out of here for a second. So if I go into my bin directory, I can do SPV_batch. And now it's not going to go to a Tickle GUI, it's just going to read the script and then start generating my reports. So I would have the two of you give that to the administrator and have them run it like this. And it's going to leave all of its data in login name, temp login name SPV. So when I'm done, I tar up that file and then mail it back to me. It looks like I have a bug, but that's because I'm running not as root. I need to run as root. Try it again.
You say it creates a file called what?
I'll show you here. So it tells me right there the path of where it's putting my reports. And then I tar up that directory, compress it, and mail it, whatever. So this is how I get past firewalls and low, slow line speeds and stuff. So right now it's getting an inventory. It's figuring out HINV, systune, grabbing a whole bunch of other things on file system layouts, checking partitioning, NQE, inter-process communication. It's running versions, everything that you can imagine that you need in an inventory snapshot. And again, when I get burned on a case study, I'll go back to the script and say, what should I have seen in the script that I missed from this example? So for example, CXFS is not dealing with CXFS mount points right now because that's not an FS tab by default. So there are little gotchas in there. And when that thing's done, whoops, it's like I still got a problem with fail-safe. So before I go on, let's see. Catch. So it's Tickle. It's easily modified. I've got several sites out that are using this so that at the end of the day, or end of the week, or end of the month, they can get their standard reports.
Now, Tickle is actually spelled TCL, right?
Yeah.
Okay.
Yeah. The Tickle allows me to create GUIs. So it's a scripting language that allows me to create windows and buttons and stuff like that a little bit easier. And all I'm trying to do right now is, since I added in some fail-safe and CXFS stuff and haven't actually played with this newer version yet, I'm turning off some error issues so that it ignores errors. So let me try it again now. So anybody that's ever used SAR before, this tool makes it easy to look at the SAR data. So right now it's still getting the configuration. It's even going through each file system and getting me fragmentation metrics, how many files are contiguous and how many files are fragmented. It's running buff view, all kinds of things that are useful to me. I think it's taking a little while because of the fragmentation. In fact, let me just log into another window here. Right now it's going through every disk drive and running FX on it. So it's basically going through and getting parameter settings for every drive. Now it's going through file system fragmentation metrics, getting me how many files are contiguous or not. So it's a verbose mode right now that's going through to pull out extract all this information for me. Now, off on my web page, this is the script that I use for my case studies. So for example, I can click in here on Disney, and then I can automatically have daily reports or weekly or monthly reports of this data. So coming out of SPV would be a GIF like that that's showing me my CPU utilization. So I got 3 days here, the 3rd, the 4th, and the 5th. And I can see their service times, their system times, and their IO wait times. So for example, General Motors has this in a cron event, and then at the end of each month, they can go to the web page and see what utilization was like for the prior month. A lot of these high-end data centers, you walk down the hall and they got a cork board up in the hallway with these kind of utilization charts pinned to it. Now PCP can do the same thing. Okay. So this is just a convenient way for me to generate the data. Go back here now. Normally I get through hardware and start software by the end of the day. I spent a little bit of time monkeying around with some things.